Okie dokie. It's always a mistake. I shouldn't do this. I really shouldn't. You know that one day when I do this, I'm going to trip and fall and take out all of my electronics at the same time. You're going to watch me fall and hit the ground, and then you're going to watch this hit the ground and this hit the ground, and see, it's stupid. Why would I do that, right? Why would I step over that?
Would we be allowed to laugh?
I don't know if you would. I think you might.
If you laugh at when we suffer, wouldn't it be fair if we laughed at when you suffer?
I'm guessing that if you want to know what would really probably truly happen, I'm guessing everybody will gasp,
Yeah, probably.
see if I'm okay, and then probably laugh.
Yeah, that's fine. For us anyways.
Because if my document camera broke, and I have to use that little stupid one, or like I busted my nose open, I might be upset. If I had broken my nose on the floor, I think I'd probably be upset if somebody in here was like losing it, like with like being like, this is my favorite day. Like I'd be like, I hate you. I'm in so much pain. Didn't we do example 1 yesterday? We went through example 3? Do you want me just to start on example 1 again, or you want me to go to example 4?
Fine.
The one that they were talking about.
1? All right, Kyle. Nobody wants to hear you. That was. Yes. This whole conversation has been recorded. Enjoy, Melanie. All right. So, we are going to be kind of prepping for doing proofs. But we're not doing proofs yet. Right now, today we're just going to simplify. All right, so write down cosecant theta, cosine theta, tangent theta. What do you think the operation is between them if I don't write anything? What did you say? Math? Okay. Nobody talked to Kyle today. Kyle's having, Kyle's being silly today. Yeah?
Wait, well, okay, this is probably dumb. It's like that times that times that.
That's not dumb. That's correct. Okay, that's what I was trying to get somebody to do. Okay, I was trying to get somebody to say that if it's not written, you assume that it's multiplying, right? Now, one of the easiest way to do these proofs and do this simplifying, one of the easiest ways to do these proofs and do this simplifying is to break it down into x's and y's and simplify from there. Because this looks like a nightmare to me. But x's and y's seem very easy. So what is cosecant?
The other one of the other.
It's 1 over y. Do you guys understand where on your unit circle to look to find that out in case you don't know?
On the bottom right corner.
Bottom right corner right there shows you that x is cosine, secant is 1 over x, sine is y, cosecant is 1 over y, tangent is y over x, cotangent is x over y. Take this out if you don't automatically know these. If you automatically know them, you don't have to take them out. Times cosine, which is x over 1, times tangent, y over x. So now I'm multiplying a whole bunch of fractions together. So talk to me about what cancels out.
The X, Y's, and the X's.
Okay, the x's cancel out, the y's cancel out. I don't really need to cancel out the x's, or the 1's. The answer's 1. Because obviously cosecant times cosine times tangent is 1. Obviously, everybody knows that. I mean, like your little baby sister knows that, okay? Everybody gets it. Do you understand how much easier it is once you break it down into x's and y's?
Absolutely.
Okay, now if your answer had turned out to be x instead, and obviously it wasn't the answer here, but let's say it was, then your final answer would need to be cosine. So you can't just leave your answer in x's and y's. You do have to transfer it back into the language of trig, okay? We're only going to do 3 examples. They will, of course, get progressively harder. Sine minus cosine times cosecant plus secant. does anybody have a plan about what we should try doing? Emma? Yes, but a specific kind of distribution that we've done before. Yeah?
Well, okay.
Pretend like they were numbers or x's.
Factor the thingy.
This is factored. We want to multiply
Oh.
it together.
Then just go boom, boom.
Right, so you could either do FOIL or you could do a box. Because see how this is four things? Like, imagine that this was like x minus 6 and x plus 8. You would do FOIL in a box, right? But first, let's change it to x's and y's. So sine is y, cosine is x. Cosecant is, well, yeah, y minus x. All right.
May I go to the bathroom?
Sure. Let's go with Katie. Do you prefer foil or the box? Okay, let's do the box. I'm gonna make this y over 1 minus x over 1 and 1 over y, 1 over x. What is y over 1 times 1 over y?
1.
Yeah, it makes y over y, which is 1, right? What's negative x over 1 times 1 over y?
Negative tangent.
Negative x over y, and it is not negative tangent. It's negative cotangent. Y over 1 times 1 over x is y over x. Negative x over 1 times 1 over x is negative 1. All right, now 1 and negative 1 are going to cancel each other out, right? And we're going to add these two together. So you're going to write your answer is y over x minus x over y. Can we put those together? No, we can't. So we're just going to write it out. This is tangent of theta minus cotangent of theta. Yeah?
Like, you put numbers in there, what they just cancel out?
No. If you take 2/3 minus 3/2, those don't cancel out.
No, that'd be more.
Yeah, multiplying would. We ready for me to move on? You okay with this so far? Thomas?
How did you get just the two?
The tangent and the cotangent?
Yeah, like the y over x minus.
Oh, and because 1 and minus 1 canceled each other out. All right, next up I've got 1 plus cotangent squared theta over 1 minus cosecant squared theta. Okay, now this problem is alarmingly simple. What we're going to be doing in this is we're going to be finding common denominators, we're going to be multiplying fractions. It's not too tough, but it is easy to mess up this problem because you refuse to write something down. I know that some of you specifically love not writing things down, and I'm just telling you, you're not above this. You're not going to be better than this, okay? So what I'm going to do is I'm going to say this is my top of my fraction, and this is my bottom of my fraction. I'm going to work them separately. And I'm going to take all my notes, be very careful. All right, the top is 1 plus cotangent squared theta, which I'm going to make into, let's see, what is cotangent? X over y, so it's actually x squared over y squared. Do you guys understand why? Because it's cotangent squared? Which would be x over y times x over y, which is x squared over y squared. And over here, I'm going to make this one y squared over y squared. Do you have any idea why I'm choosing that?
One equals y on the first clause.
That would equal 1.
No, because I want to add these together. and I'm trying to make a common denominator, and I know y squared over y squared is 1.
Oh, that's.
So now I've got y squared plus x squared over y squared. All right, now I'm going to need somebody to have a brilliant idea. Just one of us. I need just one of us to have a brilliant idea. Jackson.
Just like, no, you can't do that.
No, yeah, you can't just cancel out the y squareds because it has to be something you can take out of both, right? So that doesn't work. Someone have a brilliant idea. Emma. No, because there's not something in both you can factor out. Caitlin? No, because we're not solving for anything. There's not like an equal sign, you know what I mean? So we're not solving for anything at this point. Kyle?
I'm gonna cancel out the y squared on the bottom.
No, because you can't just cancel 1 out of 1.
Just wait, let me check my notes quick, cause I know it's. Can you multiply it by like a negative x squared?
No.
Or
I mean, you could do that.